Now, when it comes to your workloads on your data warehouse, be cloud data warehouse or on-premise data warehouse, you can essentially split them into two types. The first one is your analytical workloads or analytical queries. Now, these queries are essentially aggregation type of queries used for reporting or data science purposes, right? You select, you sum up a column, you take a count of another column, or you apply some aggregate functions and you select a bunch of other columns and you group by them. Now, this is a typical analytical workload. The next type is your point lookup queries. Now, point lookup queries are the queries that literally select all of your columns from the table and expect a few rows in return using a where predicate clause. Okay. Now, this where condition might not necessarily be one of your clustering keys. Okay, let's say you have a table, line item, something we've seen in the past, and you have a downstream application that constantly queries this table and does not use the clustering key, and it's expecting all of the columns literally. So these kind of queries that select all of the columns and expect a few rows are called point lookup queries. So a table like select star from table, a query like select star from table where column name is equal to some value is a point lookup query. So how do you go about optimizing your point lookup queries? This is exactly where you can leverage a feature called search optimization. Now, before we see this in action, I want you guys to perform a sequence of steps. So let's go back to our Snowflake account. First of all, make sure you have switched to sysadmin role. Now, for this purpose, I'm going to create a new database called testdb underscore SO indicating your search optimization. Inside of this database, I'm going to create a schema called test underscore schema, and I'm going to put that in context. Next up, I want you guys to create two tables. The first one will be called line item underscore no SO, which will be basically a clone of the line item that we already have. And the second one will be called line item underscore SO. Again, clone of the line item that we have. Now, once you do this, just pause the video maybe and execute each of these commands in sequence. Now, once you do that, let's fire a point lookup query. So let's say your downstream application is firing this query. Now, we know the table is not clustered on the order key. The table is clustered on L underscore ship date column, right? So let me execute this and let's see what happens. So it took 3.6 seconds. Let's click on the query ID. Now, if you look at the profile overview of the query, you'll realize it has scanned literally all of the partitions that the table has. It has 9,336 partitions, and the point lookup query that we just executed ended up scanning all of the micro partitions. Now let's run another one. Let's say I say select star from no SO, where part key is equal to some value. It took almost 3 seconds. Let's see the micro partition scan. Again, it scanned all of your partitions. Okay, and the remote disk is 89%, which is quite high. So what do? This is exactly where you need to enable the search optimization feature. But before you actually enable the search optimization feature, which is just one line of SQL, you have to have an estimate of how much it is going to cost you. So you have a function called estimate underscore search underscore optimization cost, which takes this one parameter. Now this parameter is the name of the table that you wish to enable search optimization for. Okay, if you are giving it a table name in which you already have search optimization enabled, it's going to give you an error. So I've given it a name line item underscore no SO because that's the table which does not have search optimization enabled. Let's execute this. Now it'll tell you the name of the table, and this object cost partition is telling us how much would it cost for us to enable the search optimization feature in this table. So it's going to cost me roughly 13 credits. That's what it means. This is an extremely important function. Next, you have your storage cost. When it comes to search optimization, it makes use of your storage and compute power as well, even when it comes to maintenance. So 0.07, as you can see, is the amount of storage that will be utilized in order to execute or implement and maintain your search optimization for this table, line item underscore no SO. And when it comes to an estimated maintenance cost, it requires at least 7 days of history. So we'll look at it later. Now let's close this. Now next up, I want you guys to enable search optimization on the table line item underscore SO. Okay. And then we're going to compare this table line item underscore SO with the no SO one. So if you execute this command, you can just pause the video and give it like 10 or 15 minutes and come back, because it's going to take a while for Snowflake to actually execute search optimization or enable it in any table. So once that is done, you can actually fire this command, show tables like line item underscore SO. So let's run this. If you've just run this query, all the table, and added the feature search optimization, and then you run this, show tables like, initially, at least for 10 or 15 minutes, this value is going to be 0. You can see it tells you search optimization has been enabled. So it says on, and then the search optimization progress is 100. Now, if you just enabled it and fired this command right away, it's going to be 0. All right. So just give it 10 or 15 minutes. Now, I'm going to fire this query, select star from line item underscore SO, where order key is this. Now, if you notice, I'm going to fire this query on a table that has search optimization enabled. All right. So let's run this point lookup query. So you can see it took like 1.606 seconds, which is quite less compared to what we had before. Now, if you go to the query profile of that query, you can see the partition scanned. It only scanned 25 partitions. So that's how optimized search optimization is. And you can see here, it accessed the search optimization, right? Which reduced the number of scans. It pruned almost 90% of your micro partitions. Now let's go back and fire the same query in the table that does not have search optimization enabled, right? I'm using the exact same column name and value name. Now it took 1.7 seconds. I'm certain it came from the cache, but let's have a look anyway. Now you can see the remote disk IO is just 13%. So I'm certain, yep, percentage scan from cache is 96. So that's why the query was faster. But let me execute on a different column. Just copy this. And I'm going to use the supply key now on a table that does not have search optimization enabled. Okay. So let me run this query. You can see it took 3.2 seconds. And it literally ended up scanning all of the micro partitions, and the remote disk is 92%, which is extremely high. Now let's come back and run the exact same query in the table that has search optimization enabled. So it was relatively faster, 1.79 seconds. Now you can see it accessed the search optimization feature, and it only scanned 877 partitions. All right. And the remote disk IO is just 7%. So that's how beneficial search optimization can be. Now, if you want to drop your search optimization from a table, you just need to say all the table, name of the table, and just say drop. I'm not going to run this now, but if you want to disable it, this is how you do it. Now, the next question is, what kind of tables benefit from search optimization? First off, if your tables are not clustered, keep in mind not all tables need to be clustered, right? This is something we've looked at in the past as well. If your tables are not clustered and the tables are frequently queried on columns that do not use the clustering keys, let's say you have a bunch of queries running every day on a table that has terabytes of data, and these are point lookup queries, and they don't essentially make use of your clustering keys. So this table can be a good candidate for search optimization. Now, search optimization feature impacts cost. It has a direct impact on cost. It is not a free feature. It makes use of your storage resources. It also makes use of your compute resources. Now, the cost depends on completely, it relies on the number of tables using this feature and also the amount of data in the table. Ideally, you should enable search optimization feature for tables that have multiple terabytes of data. So that was all about search optimization. We've seen how important this feature is and how handy it can be. It can improve your point lookup query performances by orders of magnitude. So I hope that was pretty clear. Thanks for watching, and I'll see you guys in the next video.